All right. We'll need to get the lights here in just a second, but so you guys are in for a treat. I'm really excited to be able to introduce Abby Bollenbach. Abby has advanced her astronomy interest from the early age of 10 when she studied at Khan Academy on her computer at home for 2 years. She's been a member of the Bartlesville Astronomy Society since 2015 when she attended her first star party. Bollenbach has been a presenter for BAS since 2016, providing not only monthly PowerPoint summaries of, topics such as current astronomy news, but also present on main topics such as famous rocket crashes, how to make an astrophotography tracking mount, and how to do a PowerPoint presentation. In 2016, Abby was one of the principal organizers and founding members of the BAS Youth Auxiliary Group that we got to hear this morning. The Bartian Youth Astronomers, we all love that. That is just so fantastic. Where she also presents the monthly news and occasionally presents on, that's kind of so occasionally presents on main topics, assists with meetings, greets attendees, and helps set up new members and visitors. In addition, she has enjoyed assisting with and presenting for multiple outreach programs in the BAS and is provides in local schools, festivals, and libraries. Abby particularly delights in astronomical observation opportunities like the group star parties and last year's Bartian Youth Astronomers Total Solar Eclipse trip that we got to hear about earlier in Boonville, and touring the Morrison Observatory in Fayette, Missouri as well. Abby was very recently selected by the Astronomical League for the prestigious Horkheimer-Smith First Place Youth Service Award. And as such, she will be sent on an expense-paid trip to this year's Alcon 2018 convention in Minneapolis. Now 16 and a homeschooled high school sophomore, Abby's looking forward to attending aerospace pre-engineering courses this fall at Tri-County Tech in Bartlesville for her junior and senior years. She's planning to continue her education after high school, focusing on astronomy and or astrophysics. Abby's involved in many activities in addition to her astronomy studies, including ballet, writing, poetry, singing, guitar, and photography. She's also a very accomplished pianist, as the state first place piano winner in the 2015 Oklahoma Music Teachers Association competition, as well as the 7 consecutive year top winner of the National Piano Guild with the American College of Musicians. So please join me in welcoming Abby.
I don't know if I can live up to that. I am so excited to be able to be here and present this for you guys. My name is Abby, like Rick said, and I'm going to be presenting on the Cassini-Huygens legacy. I still can't tell you guys how much I appreciate you letting me be able to be here and give this to you, so I'm really excited. How I fell in love with Cassini, a lot of people ask me this question, and I never really fell in love. It was already there. I was born in 2001 and it launched in 1997, so it's been with me like my whole entire life. And ever since I was little, I always loved Saturn because sadly, before I was into astronomy, I liked astrology. And Saturn just happens to be the Capricorn, which for December, the planet. So I was like, ooh, Saturn's really cool. And so I've always loved Saturn. And then I discovered Cassini when I was like, I don't know, 6 or 7, and I would see pictures on the news, and I was like, wow, Saturn is so cool. And it's always stuck with me, so I've loved it, and I was super sad whenever it died, but it has given us so many memories and so many gifts that we probably aren't going to be able to unwrap for a very long time. So without further ado, I am gonna give you my presentation. So the legacy of Cassini lives in the mountains of data. The scientists are going to be studying for decades to come. 2.5 million commands executed, 635 gigabytes of science data collected, 294 Saturn orbits completed, 162 targeted moon flybys, 453,048 images taken, 183 main engine burns, 2 oceans discovered on Titan and Enceladus, 3 Titan seas and hundreds of small lakes discovered, 3,948 science papers published, a 4-year primary mission, 2 extended missions, the Equinox mission from 2008 to 2010, and the Solstice mission from 2010 to 2017. In this presentation, I will merely touch on a small fraction of this extraordinary endeavor. Cassini-Huygens' official mission name originated with 17th century astronomers. Cassini-Huygens was a Dutch astronomer and was the first to observe Saturn's largest moon, Titan. He developed the balance spring watch and invented the pendulum clock. He also developed the wave theory of light, paving the way for quantum mechanics. Italian Giovanni Domenico Cassini was a mathematician, astronomer, and engineer. He discovered the Saturnian satellites Iapetus, Rhea, Tethys, and Dione. In 1675, he discovered what is known today as the Cassini division, the narrow gap separating Saturn's rings. The two astronomers collaborated and competed during their lives, which helped astrology evolve into astrophysics, creating a new expedition to Saturn. Also, quick note, this is Earth. I think they probably gave us a news flash and said we need to say cheese, but I might have missed one.
We're in that picture.
If you zoom in. The Cassini orbiter should not be thought of as simply a sophisticated collection of propulsion mechanisms, sensors, and microprocessors. Scientists and engineers view such a craft as an extension of our limited human perception. So now I'm going to talk to you a little bit about the construction of the Cassini orbiter. From Galileo to Cassini-Huygens. In the early 1980s, the space science community envisioned that the Cassini mission would be very similar to the Galileo mission to Jupiter. Both spacecraft would travel through the solar system to a gas giant planet, exploring the body itself, as well as its satellites, magnetic fields, and trapped particles. Both would continue the exploration that had begun with the Pioneer and Voyager. Developing a mission to Saturn. This NASA mission was not done serially. Mission planners did not wait for complete results and full processing for the data from one mission before they began another. If they had waited, then exploring the solar system would have taken much longer. The European space scientist community were considering building a vehicle that would orbit Saturn and conduct field and particle research, while the US supplied a probe to explore the veiled moon, Titan. This was actually the inverse of what happened. It was US that eventually built the orbiter and Europe the probe. It was $3.4 billion and nearly a decade of development. The final design of Cassini. 2 major elements made up the vehicle, the Cassini orbiter and the Huygens probe. Built into the orbiter were the sensory organs that allowed it to move in useful ways. Its navigation, altitude control, propulsion, and power systems. The technology for stabilizing the vehicle as it flew through space operated very differently than for Galileo, which, like a gyroscope, used its spin as a means of stabilization. Cassini-Huygens used a 3-axis stabilization strategy in which the desired attitude was maintained by sensor-controlled thrusters and reaction wheels. 4 main modules stacked together made up the Cassini-Huygens spacecraft and was about the size of a bus. The 4 optical remote sensing instruments on Cassini were the composite infrared spectrometer, the imaging science subsystem, the ultraviolet imaging spectrograph, and the visual and infrared mapping spectrometer. Fields, particles, and wave instruments examined the environment in the immediate vicinity of the vehicle, measuring the magnetic field and the masses, electrical charges, and densities of atomic particles. They also analyzed the quantities and compositions of dust, the strength of plasma, and the characteristics of radio waves. I have here a Haynes Owner's Workshop Manual for Cassini-Huygens. Normally, Haynes produces manuals for repairs on trucks and cars, and so when I saw that, I thought it was gold. I was like, wow, that is so awesome. I couldn't resist, I had to get it. But I've got a couple of books and some posters, and then I've got my paper models up here that you guys can view after my presentation, but they're kind of cool, so. I thought that since I was going through all the complicated organs of Cassini, you might find a couple of those in there like I did. There's a couple of inside jokes too. They'll explain a DVD section on it that's behind Huygens. That's pretty funny, but. Using plutonium to run a spacecraft. NASA and the space programs have usually maintained excellent relations with the public, both in the US and abroad. But one practice on Cassini-Huygens, Galileo, and other missions triggered vehement controversy was the use of plutonium to generate shipboard energy. Why did NASA use radioisotope thermoelectric generators for shipboard power? It's important to understand that an RTG is not a nuclear reactor. It uses neither fission nor fusion processes to produce energy. RTGs generate their power through the heat that is liberated by the natural radioactive decay of plutonium. Solid-state thermoelectric converters turn this heat into electricity. What makes radioactive materials so suitable for supplying the power needs of a space vessel is that they constantly emit thermal energy, regardless of the direction the craft is pointing, and they remain reliable even in hostile environments, such as inside a planet's radiation belt. There was a lot of public opposition to the use of plutonium and attempts to stop the launch. On October 4th, 1997, 800 protesters showed up, 27 of which were arrested at Cape Canaveral Air Force Station in opposition to the launch, which was then scheduled for October 7th. The protesters were worried that should the Titan IV rocket ferrying the orbiter into space suffer a catastrophic mishap during launch, it would vaporize the 73 pounds of plutonium-238 that Cassini carried and spread radioactive decay and radioactive fallout across central Florida. The Green Party even went so far as to file a federal lawsuit against the government in a Hawaiian court to halt the launch, but obviously, thank goodness, it was dismissed. So now the big part, the launch. The journey to the ring planet Saturn begins with the liftoff of the Titan IV-B Centaur rocket, carrying the Cassini orbiter and its attached Huygens probe. The liftoff was at 4:43 a.m. on October 15, 1997, from the Kennedy Space Center. And I have here a really cool video. The exciting moments.
T-minus 15 seconds. T-minus 10. 9, 8, 7, 6, 5,
Anticipation.
4, 3, 2, 1.
And blast off!
Liftoff of the Cassini spacecraft.
Again,
on
this was
30-mile
a
trek to
gorgeous
Saturn.
night launch. One of the prettiest ones.
Pitch program is in. Roll program is in.
Absolutely
We have
beautiful.
cleared the tower, and the Cassini spacecraft is on its way to Saturn. T plus 20 seconds. All systems are go. Jupiter Inlet Tracking Station now acquiring data.
It is, I love it.
All systems go.
To me, it seems just so elegant. Gracefully flying up there. Obviously not gracefully, but it's perceived.
Everything is go at this time. All systems are go.
So from Earth to Saturn. The Cassini-Huygens mission was split into two major phases, known as the cruise and the tour. The cruise phase involved all activities getting from Earth to Saturn, including gravity assists, trajectory corrections, and instrument testing, and various observations along the way. Gravity assists of the planet gave it a speed boost like a slingshot. During the cruise phase, the craft carried out several major mission maneuver flybys. Venus, April 26, 1998. Venus again in June 24th, 1999. Earth, August 18th, 1999, and Jupiter, December 30th, 2000. The tour phase began with the spacecraft arrival at Saturn. Cassini-Huygens took nearly 7 years after its 1997 launch to reach Saturn. As a dramatic finale to its journey through interplanetary space, Cassini-Huygens entered Saturn's orbit on July 1st, 2004, traveling a total of 2.1 billion miles, even though Saturn is only 746 million miles from Earth. To me, that's crazy. The Huygens probe was built and operated by the European Space Agency, and in 2005 became the first spacecraft ever to land on Saturn's moon, Titan. It was the farthest landing from a moon from Earth a spacecraft has ever made. Huygens separated from the Cassini orbiter on December 25th, 2004, and landed on Titan on January 14th, 2005, near the Xanadu region. That to me would be the best Christmas present ever if I was in that operating room. I'd be like, yes! Successfully detached, it landed. Oh, and I would believe in Santa. This is the only landing accomplished in the outer solar system. It was also the first landing on a moon other than our own. And here is a video of it. Coming into atmosphere with orchestra behind it, obviously. Obviously Titan was super happy that it was coming into atmosphere with the happy music, but it's, as you can see here, it's traveling down at the bottom right-hand corner of the screen, 9 kilometers above surface and 19 kilometers per hour. It gets closer and closer, and look at that beautiful mountainous range. It's gorgeous. And there's not a lot of turbulence. Super smooth. 1 kilometer up. (70 kilometers per hour), slowing down gradually. And it hits. Wow, that is the surface of Titan. It is outstanding. You will see the parachute shadow coming up right here. To me, that is just so fantastic. That to me shows the advance of man. It parachuted down onto land, although the possibility that it would touch down in an ocean was also taken into account in its design. The probe was designed to gather data for a few hours in the atmosphere and possibly a short time at the surface. It continued to send data for about 90 minutes after touchdown. Measurements of the winds were possible by studying how the molecules present in the moon's atmosphere moved. This was achieved by following the faint infrared light they emit. As Huygens traveled through the Titan's alien nitrogen atmosphere, it was carried by the wind. Computer modeling of the atmosphere, based on the winds, revealed that it is like a giant conveyor belt, circulating the winds from north to south and south to north. Titan has a hazy, thick atmosphere, which Huygens found to be even hazier than expected due to the presence of aerosols and dust particles. Scientists were also surprised to find that the 2 noble gases, xenon and krypton, were not found. Measurements of the atmosphere confirmed that complex organic compounds, the building blocks of the amino acids necessary for life, were present in both gas and solid phases. Despite atmospheric haze, the cameras on board the Cassini-Huygens probe were able to take clear images of Titan's surface. This image of the surface showed a world that resembled the Earth in many ways, with evidence that liquid methane had flowed on the surface, causing erosion. The Huygens probe also measured the weather condition of the surface, a temperature of minus 170 degrees Celsius, and an atmosphere pressure slightly higher than Earth's. Titan observations by Cassini orbiter. Titan is Saturn's largest moon and is the 2nd largest moon in our solar system. It is named for mythological Titans, the brothers and sisters of the Greek god Cronus. If it were not orbiting Saturn, Titan could be considered a planet, as it is larger than Mercury. Look at it dwarfing that little moon right there. Like this. Titan is covered with a thick atmosphere that some consider it to be smaller than that of early Earth. Titan's diameter is 50% larger than Earth's moon, making it among the largest natural satellites in the solar system. The most abundant gas is nitrogen, and methane and ethane clouds, and thick organic smog. Its surface has liquid hydrocarbon, ethane, methane, and propane lakes, and the vents of cryovolcanoes distributed among areas of bright and dark terrain that show evidence of some impact cratering. Also, if any of you were here early yesterday morning, well, it was for the first presentation, Caitlin did a fantastic presentation on cryovolcanoes, and I was amazed by her. It was great. But I had a really long talk with her about cryovolcanoes afterwards, and because I told her about Titan, and she's like, "Oh, you're gonna do a presentation," and she got so excited because she, on her side job, because she mainly focuses on Pluto, she does Titan as well, so we kind of collaborated and had a little geek frenzy moment over there. Alrighty, here is a little short video of Titan's lakes. It's a colorized movie of Titan's hydrocarbon seas. Titan's seas are actually named after mythological sea creatures. Like, I love the Kraken mare. It is also the largest sea on Titan, 630 miles.
What's the blue versus the dark?
The deeper parts of the lakes. So the lighter parts would be the more shallow of methane, marine methane. I think this is so cool that they have the technology, they were able to do this. They did this from 2004 to 2013 with radar instruments. That was so cool. Titan is thought to have several layers as well. A rocky core surrounded by layers of crystalline ice. It is likely that the core is still hot, with a layer of liquid water and ammonia. Like other moons around their primary planets, Titan has a rotation period the same as its orbital period. That means it turns on its axis in the same length of time as it takes to orbit Saturn. Titan may have formed as material in orbit around early Saturn as it began to accrete. Giant impacts with collisions may have disturbed the orbits of Titan and other moons into their current positions. My favorite, the Saturn tour. The orbiter performed admirably during the 4-year prime mission, completing in good shape and with ample propellant remaining. In April 2008, NASA announced a 27-month extension through September 2010, the Equinox mission. Named after the impending Saturnian equinox in August 2009. The second extension was the 7-year-long Solstice mission. And Cassini's entire 13-year mission was less than 1 Saturn year, which is equal to 29.5 Earth years. Here are the 294 complete orbits Cassini made. NASA also refers to this as the ball of yarn. There's also a little animation of it, 3D version. Kind of makes me dizzy. A great natural laboratory. Here comes the pretty pictures. Saturn is the 6th planet from the Sun, and the most distant that can be seen with the naked eye. Saturn is the 2nd largest planet and is best known for its fabulous ring system that was first observed in 1610 by the astronomer Galileo Galilei. Like Jupiter, Saturn is a gas giant and is composed of similar gases including 96% hydrogen, 3% helium, and some methane. It may have a liquid or metal rocky core. As a note here, in this absolutely beautiful image, as the sun backlights Saturn, you can see Earth again, right here. And I also have this picture up in the back. It's by the bathroom, break room, I guess, section. And there I've got a bunch of Cassini posters, and I had to get that. It is so, so, so pretty. With its extensive ring system and its 62 moons, many scientists believe it can be a mini model of our own solar system. Saturn is a megagiant at more than 700 times Earth's volume, but the core is thought only to be a bit larger than our own planet. A royal crown. I think it's meant for me, but I guess I'll give it to Saturn. Hexagon jet streams of the North Pole were first revealed by the Voyager mission in the early 80s. Cassini observed this behemoth storm during Saturn's winter when it was in shadow. This six-sided jet stream was first observed in the infrared by Cassini. As winter rolled into spring, images using visible wavelengths of light revealed a bizarre symmetric shape 20,000 miles across, with wind speeds reaching 200 to 300 miles per hour. Each of the cloud's six sides is about 8,600 miles long. That's longer than the diameter of Earth at 7,926 miles. Here's another short video of the hexagon, also done by Saturn, or NASA's Jet Propulsion Laboratory. The movies will be in black and white at first, and then the second one will be in the false color. And they're little quick images compiled together, so they're like a GIF. They'll be repeated 4 times. To me, that just looks so violent, but so beautiful. Almost like a live painting. And here it is in false color. To me, this looks like it's on a trip of LSD, but it's my own personal opinion. Also, it will show you the North Pole vortice. It will be looped 7 times, and it will be imaged in infrared. To me, this looks really violent, way more violent than the other one, but maybe that's just because it's red. And then here it is. But I'm just glad that we don't have those here on Earth. The eye of this spinning cloud circling the hurricane-like storm appears in dark red in NASA's false color image. It is the North Pole, about 1,250 miles wide, 50 times wider than a hurricane on Earth. The hexagonal jet streams swirling around it appear as a yellowish green. Right here. There's also a second vortice, contrasting in teal right here. Get my little laser to pull up. You've got the muted orange color tones in the low-lying clouds, and then the top right is Saturn's rings in vivid blue. Cassini also witnessed enormous polar vortices at the South Pole as well. The lightning. I love lightning, and so lightning with Saturn makes it even better because it's Saturn. So early in the mission, Cassini censored so-called herd lightning in the form of radio waves. But in 2009, the cameras finally captured images for the first time of Saturnian lightning. Scientists even made a video of it. Before I switch images, this is called the Dragon Storm. Rightfully so. Here is the video. A quick video. If only lightning sounded like that here. These storms, for some reason, generally occur at only one latitude, and only one storm at a time at that latitude. And sometimes there is no storm at all. It's as if there was only one place on Earth that had a thunderstorm. Saturn's lightning storms appear at about 35 degrees south, in what scientists have nicknamed Storm Alley. Like many of the other planets' atmospheres phenomenon, such as storms can be remarkably persistent. For instance, Cassini saw one lightning storm that began in January of 2009 and raged through into October. Lightning storms can grow in a hurry on Saturn. On December 5th of 2010, scientists captured an image of a small white spot about 800 miles north to south and 1,600 miles east to west. In less than 3 weeks, the storm had almost grown 8 times from north to south and had completely encircled Saturn by January in east-to-west direction. It was shooting lightning bolts at the rate of 10 per second. The 30-year storm cycle. This megastorm cycle in December 2010 serendipitously happened 10 Earth years early. The phenomenon roared for 2/3 of an Earth year and wrapped 190,000 miles around Saturn. Saturn's axis is tilted like Earth's, so it has seasons. But the long Saturn year of 29, thank goodness it's not 200, 29.5 Earth years produces seasons that last 7 Earth years. Can you imagine a 7-year summer or a 7-year winter? It would be the New Age Ice Age. Oh, that would be horrible. Known as the Great White Spot, this seasonal storm picks up water vapor and other materials as deep as 100 feet below the cloud tops. This vapor freezes, causing the famous whiteness of the storm. It takes this cycle approximately 30 years to regenerate conditions for the next megastorm. Cassini was also able to study Saturn's atmospheric composition, the thermosphere, and auroras. So on to the auroras, which is my second favorite part. I mean, who am I kidding? Saturn's my favorite part. Cassini was able to directly observe Saturn's magnetosphere by mapping the magnetic field and energized gases influenced by it. Here's a quick video of a cute little aurora. It was also able to observe directly how it affected the auroras. Saturn's magnetic field has north and south poles, like a magnet's field that is almost perfectly aligned with the planet's rotation.
Air breathes out when the field is weak.
I need to turn the volume down on that. Cassini was also able to measure the flow of charged electrons and ions from the solar wind around the spacecraft. I'll fast forward this a little bit. But coming in on the left is the solar wind. So you see it warping the magnetosphere. And that creates the magnet tail. And then if I fast forward a little bit more, it gets smaller and smaller, and then creates the current sheet. It was able to observe how moons and rings were releasing material into the magnetosphere, interacting and modifying it. The first indication of the presence of the huge plume of water ice and dust particles that comprise the E-ring was from observations of how Saturn's magnetic field was first detected. The radio waves produced by Saturn's magnetosphere aren't powerful enough to be detected by Earth. Cassini, however, measured a type of radio emission that was expected to reveal the rotation period of Saturn's magnetic field, which should be by true length the planet's day. Oddly, Cassini measured this rotation at a much slower rate than Voyager did 25 years earlier. Many ideas have been proposed by scientists to solve this magnetic enigma. Some scientists suggest the magnetic field is slowed down as it drags through the E-ring particles of Enceladus. Cassini measurements of the magnetosphere have changed our understanding of Saturn's magnetic field completely, and we still have many questions to answer. So now on to what we've all been waiting for, the rings. Saturn's rings are telltale features, making the most recognizable world in our solar system. Saturn's rings are made up of billions of particles that range in size from tiny dust grains to objects as large as mountains. Also, this kind of reminds me of like a little parhelion. It might just be a little rainbow, but we can just say it's a parhelion on Saturn. A cute little, have you ever heard of, what's it called? Sundog, yeah. So a little Saturn sundog. Rings can ripple or be corrugated, some morphing constantly and some are stoic. Some are diffuse and some are as thick as snowbanks. This compilation is over 92 images, over 9.5 hours of the B-ring, showing the outer edges varying with time. And so cool. Cassini beamed radio signals of 3 different radio wavelengths through the rings to make a compilation color map of particle sizes. These are made up of chunks of ice and rock, believed to have come from asteroids, comets, or even moons that broke apart before they reached the planet and are difficult to mathematically model. Saturn's rings are divided into 7 groups, named alphabetically in order of their discovery. We've got the A ring, B ring, the C ring, D ring, the E ring, the F ring, and last, the G ring. The F ring is kept in place by 2 of Saturn's moons, Prometheus and Pandora. These are referred to as shepherd moons. Other satellites are responsible for creating divisions in the rings, as well as shepherding them. Like here in this little short video. An amateur astronomer put this video together. It's on the Jet Propulsion Laboratory NASA website. The Saturnian rings stretch out more than 120,700 kilometers from the planet, but are amazingly thin, only about 10 meters thick. From top to bottom, only as tall as a 3-story building. These rings are 30 million times wider than they are thick. Cassini found the outside diffuse E ring is made up of water jets, ice, and gas from the moon Enceladus as it orbits the planet. It also observed in ring studies propeller-like features, sometimes several thousand miles long. Moonlets, a half a mile in diameter, gravitationally influence the ring particles, causing them to launch hundreds of feet above and below the rings, unlike a boat from a wake, awake from a boat. Particles farther from Saturn move slower than the moonlet, and particles nearer Saturn move faster than the moonlet. Alrighty, here's another quick movie. This movie begins looking forward, the lit side of the rings from about 9 degrees below the ring plane. It ends when the spacecraft is 8 degrees above the ring plane. I kind of get dizzy watching this and disoriented because right about here it looks like it's just going back. And then this is a really neat animation created using 36 raw images. Sergio Margio Fagundes, an amateur astronomer, also processed this. So the rings rippling. Saturn's equinox. Saturn's equinox happens only once every 15 years. For 2 brief periods, as Saturn orbits the Sun, the ring edge points directly edge on, giving both northern and southern hemispheres equal amounts of sunlight. The equinox on Saturn produces elongated shadows, magnifying ring features too subtle to have been observed before this mission. Icy clumps in the rings cast tall shadows upon the rings, much like a person's longer shadow on the sidewalk with the sun set to their back. Scientists have surprised to measure the largest shadow casting features in miles rather than feet. Right here, imagine this like the Rocky Mountains, and then like a huge Rocky Mountain strip, and then these in miles. To me, I can't, that's just a shock. I can't look at that and have that perception.
So it's not that it's miles thick, it's the shadows.
The shadows are miles long, yes, yeah. Some of the icy clumps turn out to be as tall as the Rocky Mountains. That's why I guess I can't imagine that. Over the span of about an hour, the small moon, Epimetheus, orbits beyond the rings as it moved across Saturn's A ring, and this movie made up of 21 images. Spokes. Poorly understood and first seen by Voyager in the 1980s, spokes got their name due to the radial wedge-like features in Saturn's rings, that rotate along with the rings like spokes of a wheel. Icy particles are probably lifted above the ring surface by an electrostatic charge. They can be greater than Earth's diameter and longer than 10,000 miles. They can come and go very quickly, despite their often enormous size. The moons. When Cassini launched, 18 moons were known to exist, and 13 more were thought to exist. By the end, 53 were confirmed, and another 9 marked as conditional. I am not going to attempt to name all of the 62 moons, but here are some beautiful images of some of Saturn's moons. This right here is the little emblem of the amateur astronomers at NASA that's put together some of the images. So imagine us doing that. We're getting a chance to do that. That is what I aspire. And then here's a little quick video of Prometheus. One moon name, 61 to go. And then here is Rhea and Mimas. Beautiful crossing. And here is Tethys, an up close look. To me, they look fake. This does not look real to me. Before this mission, Enceladus was believed to be a dead ball of rock and ice. At 310 miles across, this moon is small. Its icy surface is incredibly smooth in places, free of impact craters, and bright white all over. It's considered the whitest, most reflective body in the solar system. The magnetometer showed the moon's magnetic signature was more like a comet than a moon. A southern polar region flyby reveals it's been recently resurfaced. The infrared spectrometer showed this southern polar region to be 100 degrees warmer than the rest of the moon. The heat signature aligns with the 4 huge ice fissures called tiger stripes. Jets of salty water and ice shoot from over 100 geysers in these ice cracks from an underground ocean beneath the icy crust of Enceladus. You've got the Alexandria sulcus, the Cairo sulcus, the Baghdad sulcus, and the Damascus sulcus. I just think these are so cool. The geysers shoot out about approximately 800 miles per hour. This composite image view of Enceladus within Saturn's E-ring was made by amateur astronomer Val Clavins. Some of the material falls back into Enceladus, and some extend hundreds of miles into space to form Saturn's hazy E-ring. Nanoparticles of silica were detected by Cassini in the icy droplets of the E-ring. Silica can only be generated when rock and liquid water interact at temperatures higher than 90 degrees Celsius, which is 200 degrees Fahrenheit. Deep beneath the icy shell of Enceladus, scientists believe oceanic hydrothermal vents must exist. During one close flyby, instruments sampled the plume, detecting a very surprising mixture of water vapor, carbon dioxide, carbon monoxide, and other organic materials. Also, the density of organic materials was 20 times more dense than anticipated. Evidence of the internal ocean came from gravity measurements based on the Doppler effect and the moon's slight wobbling orbit around Saturn. Data suggests an ice shell about 19 to 25 miles thick, covering a 6-mile deep ocean in the southern polar region. More and more evidence is suggesting a habitable ocean. Or aliens. Always possibility for extraterrestrials. The final frontier. The final mission concluded with the 5-month grand finale phase. 22 deep dives between Saturn's clouds and innermost rings. It shows here in this quick video all of the dives. a very sad moment and ending in a huge historic. I also have a close-up video if my iPad will work. Technology, it's great. I love how we're so advanced that we can send things to Titan and Saturn, but not be able to have PowerPoint work correctly and go out of the YouTube app and have music still playing. It's kind of sad.
Microsoft. Four-letter word.
All right, let's see if this will work. Maybe. Cross your fingers. Wow, I showed you the place I wanted. And this is awesome. Mid-State Regional Astronomical Convention finally get to speak in a stupid piece of electrical junk. Video pan of the latitude to create a single continuous mosaic. NASA combined 137 images from Saturn's north polar vortex to a region 18 degrees south latitude.
Let us watch some of it.
Thought they might have been able to come with a more creative name of the noodle, but
So are these storms?
yes, that's the north polar vortex to the south 18 degrees. But yes, these are storms. But this was a video pan of the last final dives. Just pretty much continuous storms. Still kind of sad. For the final dive, on September 15th, 2017, operators deliberately plunged the spacecraft into Saturn, as Cassini gathered science until the very end. Cassini kept the spacecraft antenna pointed at Earth to send as much data as possible. The plunge ensures Saturn's moons will remain pristine for future exploration, uncontaminated by hitchhiking microbes from Earth. Until finally burning up like a meteor, the legendary Cassini signals came to an end. The historic Cassini mission was an adventure full of unprecedented discoveries. While the mission is complete, its enormous body of data will continue to rewrite textbooks for decades to come. Thank you guys so much. That is the end of my presentation.